Hi everyone, let's talk about trigonometric identities. So first, let's start with the Pythagorean identities. So where on earth do you think the Pythagorean identities could come from? Probably the Pythagorean theorem. So if you'll notice, some of it is in red. Only write down the stuff that's in red for your foldable. The stuff that's in black is just me sketching while I talk. So the Pythagorean theorem is a squared plus b squared equals c squared in a right triangle, right? So we've got 90-degree angle here. C is the hypotenuse. A and B are the other two sides. And we can use a squared plus b squared equals c squared to find the length of any side in a right triangle. So Pythagorean identities, let's think about a triangle in the unit circle. So we've got theta here. We've got X and Y. So I pop that triangle out over here. Nope. And I draw it like this. I've got my 90-degree angle over here and theta over here. And we have X here and Y here. So remember that we can always rewrite X as the cosine of theta, and we can always rewrite Y as the sine of theta. So I can rewrite this as cosine theta. I can rewrite this as sine theta. And the radius of a right triangle in the unit circle is always going to be 1. So I can use the Pythagorean theorem to say that x squared, aka cosine theta squared, so I can write cosine theta squared plus sine of theta squared is equal to 1 squared. And I took that right from my picture right here. In trig, we usually rewrite this whole piece squared as cosine squared theta. It just helps us distinguish between and this because it gets confusing. So we just rewrite cosine squared theta or cosine of theta squared as cosine squared theta. So I'm going to do the same thing with sine squared theta, and that all equals 1. So that is our first Pythagorean identity for trig. They usually just put sine squared theta plus cosine squared theta equals 1 first. Like they usually put the sine squared theta first. I don't know why. These are obviously both the same thing, but we're just going to memorize it as sine squared theta plus cosine squared theta equals 1. So that's going to be our first Pythagorean theorem. Sine squared theta plus cosine squared theta equals 1. And then let's talk about the reciprocal and the quotient identities before we go back and fill out the rest of the Pythagorean identities. So the other identities that you need to know for trig, and we use these to like rewrite trigonometric functions when we're trying to solve them. So that way they're just easier to do. Like it's much easier to think in terms of sine and cosine rather than cosecants and cotangents and all that stuff. So we like to often rewrite the reciprocal identities in terms of sines, cosines, and tangents. So the cosecant of theta can be rewritten as 1 over the sine of theta. The secant of theta can be rewritten as 1 over the cosine of theta. And the cotangent of theta can be rewritten as 1 over the tangent of theta. So I don't know. Of course, you're going to be able to find your own little relationships for what goes with what, but I always think of like cosecant goes with sine because you would think that like secant would go with sine because they both start with an S, but it's the opposite of what you think. So secant goes with cosine and cosecant goes with sine. I don't know. That kind of helps me remember. Also, cotangent and tangent always go together because they're codependent. I don't know. I remember that too. So the reciprocal identities are those, and then the quotient identities allow us to rewrite tangent and cotangent in terms of sines and cosines, which is super helpful when we're trying to solve trigonometric equations or functions and stuff like that. So the tangent of theta can be rewritten as the sine of theta over the cosine of theta, and the cotangent of theta can be rewritten as the cosine of theta over the sine of theta. So back to the original Pythagorean identities, right? So I'm going to make this a little smaller. There are two other Pythagorean identities, and they are 1 plus the tangent squared theta is equal to secant squared theta, and 1 plus cotangent squared theta is equal to cosecant squared theta. So let's prove those up top real fast. You don't have to write this down. I'm doing it in black because it's just me talking. So let's prove this guy. So I have 1 plus tangent squared theta is equal to secant squared theta. So I have 1 plus, and remember, this is derived right from the Pythagorean theorem. So if I use A, B, C, so if I use my knowledge of this in order to extend it to this using reciprocal and quotient identities, hopefully you'll see where I'm coming from. So tangent squared theta can be rewritten as sine squared theta over cosine squared theta is equal to secant squared theta. So I have 1 plus sine squared theta over cosine squared theta equals, remember, secant squared theta can be rewritten as 1 over cosine squared theta. So now I have 1 plus sine squared theta over cosine squared theta. I'm going to get a common denominator here. So I get cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta is equal to 1 over cosine squared theta. So then I have cosine squared theta plus sine squared theta all over cosine squared theta is equal to 1 over cosine squared theta. If I multiply both sides by cosine squared theta, now I have cosine squared theta plus sine squared theta equals 1, which is our first Pythagorean identity. So we have gone ahead and proven that 1 plus tan squared theta equals secant squared theta, because we can rewrite it and it becomes the first Pythagorean identity, which we have already proven with the Pythagorean theorem. So we now know where 1 plus tan squared theta equals secant squared theta comes from. And then we have our one last Pythagorean identity, which is going to be 1 plus cotangent squared theta. Ooh, I hope I finish erasing this in time by the time I read the third problem. Here we go. 1 plus cotangent squared theta equals cosecant squared theta. So let's rewrite him in terms of sines and cosines. Cotangent can be rewritten as 1 over tangent of theta. That's not too helpful. Let's do it like this. Cotangent of theta equals cosine of theta over sine theta. Yes, ma'am. And this is squared, so I gotta make my other one squared here. Okay, and then we can rewrite cosecant squared theta in terms of sines and cosines. So cosecant of theta is over here is 1 over sine of theta. So I can actually get rid of that and then have more space. Hello. 1 over sine of theta. I got to square it because this is squared. Okay, cool. So now I'm going to do the same kind of thing that I did over before. I have sine squared theta over sine squared theta. I'm rewriting this 1 in terms of something that would have a common denominator with the second fraction. Okay. Woo. Now I have sine squared theta plus cosine squared theta all over sine squared theta is equal to 1 over sine squared theta. Multiply both sides by sine squared theta to cancel it out. Bye. And I now have sine squared theta plus cosine squared theta is equal to 1. That is my original Pythagorean identity. And we know that that Pythagorean identity can be proven with the Pythagorean theorem. So we have gone ahead and proved all three of our Pythagorean identities. That's why they're called the Pythagorean identity, and hopefully that will help you understand them a little deeper. So memorize all of these identities. It'll make it so much easier for you to continue on with the trig unit.